I'm Matteo Collina, and today I'm here to join with Ido from the daily.dev, and we are just waiting for people to start joining. So hi folks, everybody. I see a lot of people already joined, and wow, thank you. I see the attendee number going up, so I'm very happy. We're just waiting a little bit to start. You can just present, Ido. Ido, you can just present. If you just present instead of staying this probably nicer view, you can just hit the, yeah.
Like so?
Yeah, that would be fantastic. Okay.
Yeah,
so,
great.
Thank you. And yeah, no, it's great to be joined here. How are things in Israel, Ido?
Pretty good actually. Winter has just started, so we've had a few rainy days, but overall it's pretty great.
It's so interesting that winter has started and there is rain. Here it's like -1 this morning. I live in Italy, so here was where I live. It was -1 this morning. A few weeks back we had snow. So hey, a lot of people joining. So I think we are ready. We are ready to go and start. We're going to talk about GraphQL today. Pretty nice topic. This is a lot of people implementing GraphQL in the world, so it's very good that we can talk a little bit of a success story, and real world implementations of GraphQL, which is very often we don't get to hear from. We see, oh, this is a nice tutorial, or do this, do that, but we don't see what happens when you actually run this thing in the wheel. What's happening, okay? How things are work at a high traffic scenario, okay? So how does this thing scale? So I'm, as I said, I'm joined today with Ido Shamun, hopefully pronounce it okay, the CTO of daily.dev. Ido, why don't you introduce yourself a little bit?
Yeah, so thanks a lot, Matteo, and all the NearForm team for having me and doing this event. So a bit about myself. As Matteo mentioned, I'm Ido from daily.dev. I'm the CTO and co-founder, and I've been doing software engineering for, I don't know, like more than a decade. This is all I do, all I know, and all I breathe. And just describing daily.dev to give some context a little bit. So daily.dev is a news aggregator for development. We aggregate over hundreds of sources on a minute basis. We look for everything that's hot in the web development and development in general domain. And we create a personalized feed for you, so you don't have to look for anywhere else to get your content from. So after the webinar, give it a go and let me know what you think. You have my Twitter handle in the screen. You can the DM is open for anything you need.
It's be careful. Like daily.dev is super nice. Okay, I love daily.dev. It's a nice little tool that can help you in your day-to-day as a dev. Like I like it. I like it. Okay, so it's
thank you very much.
It's a little bit of a time server. I'm also very happy because they use a lot of my technology. So it's built on. We'll talk a little bit more. It's built on Node.js. It's built on Fastify. It uses GraphQL. There's a lot of the code that I wrote in there, even though I'm not part of that company, but they've been using a good chunk of what I did. So a couple of notes about me. I'm Matteo Collina, Chief Software Architect at NearForm, and again, you can follow me on Twitter. Super, whatever. So hey, somebody says you're part of the company.
Yeah, Chris. Chris is part of the team.
Chris says you're part of the company. Yeah, I can feel I am a little bit sometimes. It's when I see an issue, I'm joking. I'm not, but I hope you can feel it that way. So there's a good chunk of the open source stack in there. Cool. So yeah, I'm chief software architect at NearForm. What we do, we are a professional services company that focuses on using open source software and deploying it into many clients and helping companies build and scale their JavaScript applications. So happy days. So what we are talking today, by the way, the daily dev is not a client of us. Just quick disclaimer. I just wanted to say it's not a client of ours. So we just invited them because they've started using our tech and they've done such an amazing job. So it was really great to have them join on our in this webinar to talk a little bit about it. So yeah, that's so what was the problem? By the way, you want to show the daily dev website or something just to clarify exactly what we're talking
no,
about?
I already covered it. So if you want to check out daily.dev, simple as that, check out whatever you want. I'm here for anything, and we can start dive into the actual, tiny bits.
So, yeah, this is a big problem, right? Node.js keeps evolving. I'm part of the Node.js technical steering committee, and I really know the problem you're facing, that, you develop your stuff on a version of Node, and then we deprecate it because after 3 years it's gone, right? So it's going out of maintenance. By the way, you can keep using it, but you won't get security fixes. So just for everybody to see, it's not that's getting deprecated, but it's getting out of the LTS. That this means that it's getting deprecated, but it means that it's getting off the LTS maintenance cycle, which means that it's not getting any security fixes anymore. So you had this problem, right? The timeline for that is April. So at the end of April, Node 12, bye. Yeah. So hope you are all planning your migration, folks. So you're planning yours. Ido.
Yeah, so actually my story starts with your tweet, actually. I saw your tweet that Node.js 12 is about to get deprecated, no more LTS, as you mentioned. And for us, it was a good time, to start thinking about the migration. We also have been running Festify 2, and at this point, Festify 3 is already at late stages. You've been already discussing Festify 4 even. We were using Apollo Server 2, and we were looking basically to upgrade all the stack. So Node.js 16, Festify 3, Apollo Server, even to upgrade the version there. But then we started the process and we see lots of pieces starting to break when it comes to Apollo Server. And the first one was the file upload, which we couldn't sort out. And so at the time, I remember you shared Mercurius as a possible alternative for Apollo Server, and I always wanted to give it a go. And when I tried, migrating to Apollo 3, I saw that it's definitely not that straightforward and it's very much time consuming. And I also wanted to upgrade the engine of the GraphQL subscription. And all of this was pretty hard to do. So this made me look into other projects. So I wanted to try out Mercurius, as I mentioned. And luckily, the migration to Mercurius was like super fast. It was like almost like drag and drop kind of replacement, like npm install, change the middleware registration part to the right package and put the right options. More or less this was the process, and immediately I had something running, at least that I can see preliminary results and how it works and what is the developer experience like. And so, yeah, I decided to go to double down on this and complete the migration. And it was like 1 day or so of migrating, and we will soon see the results.
Yay! So you did so. This is this is pretty nice to see. Like I really like the fact that you were able to migrate it in 1 day. Okay, we've been migrating another project from Apollo 1. Okay, recently, yeah, that's, you know, everybody has some maintenance to do. Even, you know, it's not that it seems that on Twitter we are all shiny and building new things all the time, right?
Yeah.
But it's not always the case. Okay, there is also a lot of, you know, grueling work of maintenance and plumbing and you know, keeping things up. And we were doing an update, and it took a little bit more than that. It really depends on how you're building your schemas, and how you're building your schemas, especially the update to the latest GraphQL versions are a little bit. It's probably the hardest bit. Okay, just at least from my experience, it's if you're just typing that you have the schema in SDL form, it works pretty well. But if you have like tools that automatically generate the schema for you from the database, for example, it's a little bit more tricky, because then you need to update everything at the same time. So you need, because if you're using a library, because GraphQL, like if you're using GraphQL JS on a project, every single version of every single library that you have on your node modules must use the same version of GraphQL JS, otherwise it will complain badly and crash. And, you know, it's like, you know, the Ghostbuster, and that we're crossing the streams and making a lot of popcorn out of the Michelin Man, or whatever. So anyway.
Yeah, I had this problem that you mentioned with the GraphQL library. This is also like, this was one of the struggles that I had with the Apollo server, that it forced me into, you know, upgrading all at a single time, and it was too hard for me. And this is why I looked the other way. But yeah, GraphQL is like kind of peer dependency, and also the dependency of so many, and you just have to align it super hard. Yeah, I agree.
Yeah, it's tricky business. Okay, so it's part of the reason why we built Mercurius was to provide a performant implementation of a GraphQL server. It does a bunch of different techniques. I just wanted to ask, did you enable the just-in-time compilation, Ido?
Yeah, I did it. This was again one of the strengths and one of the features that I really want to try out, because we do have this, you know, like, I guess every project has this a few kind of queries that gets called very much compared to the others, and the just-in-time compilation would benefit us greatly due to the nature of our product. So I really wanted to try it out, and obviously I enabled it. Yeah.
So one of the things that Mercurius does out of the box, well, not out of the box, but you need to configure it, is to enable the just-in-time compiler. How does that work? It takes your GraphQL query, and instead of just processing it as usual using GraphQL JS, it compiles it using another library called GraphQL JIT, which was built by the team at Zalando. It's a big e-commerce company here in Europe, so you'll probably have heard of them if you are in Europe. If you're not in Europe, well, I don't know, but it's there. And you have, so basically they build this really nice library that takes the a GraphQL query, and compiles it to JavaScript. Then what your V8 runtime do, it takes that JavaScript, it optimizes it, and compiling it into binary code. So essentially you have multiple levels of you know, it starts all the way down, right? So basically there's a JIT at one level, and then there is more JIT and more level that enables more JIT at more levels. Okay, So because of that, you can have a significant improvement just by turning that on. Then we can talk a little bit about the caching bit, because it's really it was really nice. So if you go forward, if you flip the slide, what are the numbers that you were getting? Okay.
Yeah, so actually, let me go first to this one.
Yeah.
Before we reach to the other slide. So we try to monitor the performance of our APIs and servers and basically almost everything. So we wanted to see how this migration impacted our performance, whether it introduced some regression or more positively improved the performance. So we did a comparison on Stackdriver that compares the most updated version, which you can see in the orange color, to the older version with Apollo and Festify 2. So this is the blue color, and you can see how the density distribution graph shifts to the left. This means that most of the queries that we received are getting back much faster than before. So you can see that there's also, like, many of them are getting completed less than 20 milliseconds, which is, very fast compared to what we do. And you can see that even Stackdriver mentions that there's a major change in the performance up there. So obviously we were very happy with the results, seeing how we improved one of our core GraphQL queries, which is to receive the feed of news. This obviously has, tremendous impact on our business.
It's so cool and so nice to see that, some of the technologies that I've built can make a significant improvement in the wild, because it's, I always see, everybody benefits when we have faster libraries and faster tools to get content out of our users. Also, like, faster tools that have a good developer experience, because as everybody says, well, we can just build everything with assembly, right? That's super fast. So, or recode everything in whatever language, but then, there's productivity gaps. Okay. So it's not always a great choice. So it's it's really impressive to see the shift, especially like now you have even a significant number of requests. Like, if I do my math correctly, like, I don't know, 20 or 30% of the requests that ends before 20 milliseconds or something overall, considering the overall distribution of the graph, which is, really nice. Also, the number that it's more interesting to see is also the reduction of the 99th percentile in that diagram, because it's it's basically, it's almost cut down more than half into that query. Like, the top ones are around 5 seconds, and previously you had stuff running for 20 seconds. Like, even the worst case scenarios are getting significantly better. Now those are probably outliers and stuff that you might want to optimize for, but anyway, it's good to monitor them in term of things. Pretty great. And in the previous slide, the previous image, what was that about?
So, like, after I uploaded this showing off on Twitter, I upload kind of this slide. I tagged you in with joy, saying, "Hey, Matteo, look, I implemented all your stuff, and I see this massive improvement." And then you said, "Oh, but there's one more thing. You can implement the cache stuff." And so you gave me some homework to do, and I took a look, I took a peek, saw kind of in-process cache for GraphQL, which basically stores the responses in memory, so you can immediately give the response in like in a tiny bits of window frames, like several milliseconds or so. So I implemented it, and you can see that I monitor the transactions that we do for our database. And so you can see around 5:45, I deployed the new version with the cache. So you can see how significantly it drops, like the amount of queries that we run on the database. And it just stayed there. You can see it in this slide, but eventually it stabilized on this value. It didn't came back to the original high value. So again, dropping in this kind of out of the box in process cache mechanism really helped us remove some of the workload from our database.
Yes, it's really nice. So the part of the technique that Mercurius cache uses is it deduplicates the calls to your resolvers. So what it does, it intercepts the calls to the resolver, and if two users are accessing the same resolver at the same time, it's basically it coalesces those two queries into one single execution of that resolver. This means that you can actually, if everybody's accessing the main feed of an app, of your app, you can actually do one query at a time to the database of that very expensive query, and then even maintain that query for a bit of time, like a second or 2 or 10 or something like that. It's really great, because in this way you can automatically scale. Those systems actually can scale way better, because at that point you have, I don't know, for a specific resolver, for a specific set of parameters, essentially. But most public applications have a few main resolvers that are it all the time, and then a lot of long tails one. Okay, as you see in the graph that Ido, I will keep being very bad at mispronouncing. Ido, that Ido showed, you will see that there's some long tail, but there is some clusters of it. So no, it's great. So you only use the in-process one. You didn't hook up Redis, right?
No, we use the in-process one at this point.
Yeah, you could go one. I'm giving you more work to do. So there is also, we have released a new version of Mercurius. We have been of Mercurius cache, and with Mercurius cache, the latest version, what you have is you can also store your cache data in Redis, and also you can implement it, and it also supports invalidations. So you can even cache for a longer period of time, but then you need to invalidate the data when it changes. So it's a trade-off. Okay. Yeah. So you could try. We have developed that technology for one of our clients. Okay, I would say that I can say that we implemented some of that logic for one of our clients, and you can actually you can test it, because we were getting basically we use this to shift a lot of the database workload. Like the database was the main bottleneck of the application. So by using this automatic caching layer, we could on Redis, we could essentially we have actually reduced the traffic to the database to 10% overall of to what it was before. So basically, for each single GraphQL SQL query, instead we're just only 1 out of 10 was passing through the database, which was a massive result. And the database was then flying happy in the peak moments, because they were not being hit at all. And we were doing, I don't know, like thousands of comments to Redis at any given time, which was, hey, Redis, you're having a hard time serving things. Okay, so pretty good. Do you use subscriptions, Ido?
We do use those, yeah. I see that someone asked about the whether the feed is a subscription or a query. So just to answer them, it's a query, but we do use subscription for other parts of the application. So we have upvotes and comments system built in. And so while you're scrolling in the feed, we want to give you, real-time updates on upvotes and everything that's going on. So we use GraphQL subscription for this.
And yeah, no, it's pretty nice. So there was a little bit of a change in standard in GraphQL subscriptions. Have you got any problems related to that, or you keep using the old one? Because we Mercurius support, there are two main competing implementations, if you want to call them, of the GraphQL over WebSocket subscription thing.
So I think I upgraded to what you suggest on the documentation of Mercurius. So I guess I'm all
there
up
was
to
an
date.
old, so there is an old GraphQL subscription transport, I think, standard, which was like kind of old and not it's become unmaintained anymore. It's unmaintained.
Mm-hmm.
And then there is a new version of it, a new protocol for it, which is the GraphQL-WS library and protocol, which is way better and essentially the new stuff. Okay, so that's what it is. Okay, it's not.
Yeah, so I use this. Yeah. Also, one thing I wanted to mention about the cache. One of the great things I love about it is that you can provide a very straightforward function to define the key for each resolver.
Yeah.
And so in our case, almost all the application is personalized. So we don't cache things globally for all the users. We usually use the user ID as a part of the cache key. And the fact that we are a browser extension, so we have a browser extension and also a web app, but most of the traffic comes from the browser extension. This means that every time you open a new tab, you get our feed. And this means every time you open a tab, you dispatch several requests to our, our server. So we thanks to this in-process cache, even though we store it for a few milliseconds, to be honest, because our content is pretty dynamic, so we didn't want to lose that. But we did want to dedupe some of the requests. So even I think we set it for 10 milliseconds or something. Even this had a tremendous impact, the one you saw before.
So you have your code, right?
Mm-hmm.
So you're doing all those queries. How is memory going? You're doing all this in process caching. Was memory impacted at all in the memory usage of your servers? Was it impacted at all?
Somewhat impacted, yeah. To be honest, I had kind of lightweight servers, so less than 1 giga of memory for all my servers. And so I think I squeeze it a little bit higher. I change it maybe from half a giga to 1 giga or something. But it's just because the fact that I mentioned we store per user cache. So this means we get lots of these, I don't know, we have a trash hour, it can be thousands of users in real time or maybe even more. So obviously this means a lot of in-memory data.
Cool. So, okay, really nice. So give it a go to Redis. Okay, you can potentially do, you could I think you can get quite a lot of some more boost on it just by storing a lot of data of that that data in Redis. It can be a good. However, you might want to manage some invalidation. So that's a little bit more work on that side. But you might want to give it a go. Cool. No, it was really nice. Yeah. Yeah, somebody was chatting in the chat and said Redis always seems to be the answer. Well, yes, it's Redis, right? It's built in Italy. What you want. Like, it's the best. We are the best. I'm joking. Sorry. It's it's a little bit of Italian proud. We have one database of all the databases in the world that was written in Italy. So come on, I need to be proud of it. Okay, so we have Fastify, we have Mercurius, we have Redis. No, it's a great combo stack. So it's we have another questions about it. Can you dedupe the subscriptions using the caching technique? And unfortunately, not at the moment. We are, it. Yes and no. Let me be more specific. Okay. So what you can do with Mercurius is built using a library that I wrote a long time ago called MQEmitter, and MQEmitter is a very tiny bit. It's a very tiny pub/sub mechanism, so that in theory you could do that, but not with the caching, with the cache, but not with the cache. Okay, the cache does not get involved with it. Okay, so you can have a single stream of data from coming from Redis PubSub or Kafka or wherever you want, and then that gets fed to multiple clients as a fan out. Okay, it's possible, but it's a feature of Mercurius. It's not something that is part of the caching. I don't know how you use the subscriptions, Ido. So it's,
yeah, actually, we did see some kind of bottlenecks, but I think it's the way we implemented it. But we decided to dive deep into it later on this week. It's not. It doesn't have to do with Mercurius, but the way we implemented the subscription.
Yeah, that's the one of the hardest part, right? You need to, if you want, you need to, I don't know, start using, for example, these other library for MQ, like MQEmitter Redis or similar to.
Yeah, we use Redis.
Yeah, use Redis as always.
No, we already use this. Yeah.
Oh, you already use the MQEmitter Redis. You migrated to that, or you use something more specific?
Maybe something else. I have to check.
Yeah, you see, always use the Matteo stack. I'm joking, okay. Or not? I don't know. Like it's. So I built these libraries for PubSub. So this is another argument. These are passing the libraries that I'm using. And it's in the chat. So it's MQEmitter and MQEmitter Redis, but the MQEmitter has a lot of other implementations. So you can have, for example, something built on top of the MongoDB oplog. Okay, there is something that works across multiple child processes if you want to run them on the same host, or even something for Aerospike. I really wanted to build something for Kafka, and I think I did for some clients, but it's not open source. So anyway, the core part of this library, it's a really fast PubSub fan out thing. So basically, you can subscribe to something, and then when with a pattern, with a glob pattern, and then with that event happen, you actually get it. You actually get it out automatically. It's really fast.
Sorry, go ahead.
No, go. You have.
No, I just wanted to. I see another question. Wanted to answer it, but right after you finish.
Yeah, so it's those tiny libraries can get a lot of it done. Also because they are fast. As I say, they're very low overhead. I built these libraries a long time ago. Like if you look at the history of those libraries, are been around like the MQ emitter one. Let me look at the first commits. Like it's it's like older stuff, like old stuff. It's 2014. Like those are 2014 libraries. Okay, this has been in production system, and I originally developed them because I was doing a lot of work in the IoT space a few years back. So, and those libraries were extracted from some other project that I built. It was an MQTT broker. So really built to scale up and sustain a huge number of connected clients. Like I think we pushed it to 100,000 clients easy. So those things are very low overhead and really fast. So they might have an old school callback API. I'm sorry, they were built into that era. We had no promise back then, but you know, they're pretty cool. So you know, MQ Meter is getting a good number of downloads now. So it's good enough. Okay.
Yeah, so we will take a look probably later on this week or next week.
Yeah. Oh no, there is somebody that did a Kafka thingy. So I know I'm talking about Kafka. Having fun about talking about Kafka. So it's yeah, there is somebody that did a Kafka implementation of it.
Mm-hmm. Okay, so there is one question here. I see. What is the tool you are using to inspect the GraphQL query latency? Daniel asked it. So actually, it's something that, like, we use Stackdriver. It's a tool from the Google Cloud Platform suite to monitor distributed tracing, but we built on top of it kind of add-on to monitor our GraphQL queries, mutation, and all of this latency, because as you know, GraphQL endpoint is only going to /GraphQL. So this means unless you do something custom, you get all this tracing into one slot. So we actually implemented a Festify middleware that sits like Festify middleware, and also a GraphQL middleware that sits one on top of the Festify routes, and second on top of everything, every resolver that we have, and then creates a distributed trace just for this query or for this resolver and whatnot, and adds all the necessary parameters. And this is how we are able to monitor everything and to create reports and track the performance of all the queries and mutations.
This is amazing. Is all that code is proprietary, right? It's part of your stack.
Actually, our API is open source, so I can share some links later on to the right places, so you can have a look and see how we decided to implement it.
Yeah, it would be amazing. So just for people to see what production GraphQL looks like, okay? Because it's you know, a lot of people, like, as I said, read a lot of tutorials and stuff, but there is not, you know, I love stories from the trenches, as far as you know, as everybody says. Cool. No, it was a really nice journey to hear from you, and I really wanted to connect with the audience about it. So
we have two more questions, I see.
Oh, okay. Where are them? I probably missed
in the Q&A. So maybe you can answer
in Q&A.
this.
Yeah, no, I answered the question. Sorry, I didn't see them. Great. Okay, this is a nice question. Okay. It seems benchmarks and these upgrade stories suggest Mercurius is often faster than Apollo or regular GraphQL use cases. Other than the JIT plugin and caching, what qualitative difference are there between Apollo server and Mercurius? I will ask this to you, Ido, and then, you know, what's your experience with it, and what, you know.
So in terms of, the performance itself, I am not very aware to the underlying of everything going on in Mercurius, but in terms of developer experience, I had the experience of migrating to Mercurius from Apollo server. And, I mentioned it that upgrading from Apollo server 2 to 3 was almost, the hardest thing to do. But then again, migrating to Mercurius almost happened, with no efforts whatsoever. So in terms of developer experience, for me, it was just plug and play kind of, interoperability, which is great. And, also if you want to enable subscriptions, you just add it to the options. So in terms of developer experience, this is really, really cool. But, in terms of benchmarks, I don't really know what happens under the hood besides the JIT and the caching.
Let me give you a few hints. So first of all, it's Mercurius is built on top of Fastify. So if you are using Apollo on anything else than Fastify, you will get a significant boost just by switching your web frame. Okay, that's the starting point. Okay. A secondary point that you will get with Mercurius is that you have built-in data loader support, and if you're not using that, if you're not using data loader, the data loader pattern, you're probably having some very low-hanging fruits that you can get solve very quickly. So instead of in Mercurius, is as simple as instead of just specifying your resolvers, you can specify your loaders, and we'll automatically hook it up so that you have a nice pattern for implementing your data loaders. And that alone can save you enormous amount of effort. It's as part of that, Mercurius does a little bit, a little bit more wrangling of the internal GraphQL system so that it can respond to your queries very fast. So it tends to, once you enable the JIT and all the other things, it can actually, you can see it in the flame graph that it's very little happening in Mercurius, like everything gets optimized away, essentially. So basically it enables to it's one of the goals of the project is to reduce overhead as much as possible. I have a few good presentations about all the things that we do in there. Just consider it that just enabling the JIT means that you're doing a lot of other optimizations internally. So one of those is the fact that it's caching also the parsed schemas. So sorry, the parsed queries. So one of the problems that you get in the tradition in Apollo and in other GraphQL systems is that whenever you receive a query, so the server needs to take the query, parse the query, okay, parse the query, validate the query against the schema, and then execute the query against the schema. Those two operations, that validating and executing, it requires a lot of CPU time. The reason is that you need to traverse the full query and validate against the schema so that you can actually respond. However, once that validation is done, there's no need to do that validation more than once. Okay, like once you have the text of the query, you can actually do it, keep the same stuff. And Mercurius avoids all that work in general. So, which is even if you don't enable the JIT, you can actually just benefit from that, and you'll actually improve a lot of the performance. It's just avoiding that very heavy step. So happy.
Yeah, actually, you mentioned data loaders. So I wanted to point out our strategy of how we do GraphQL queries.
That is amazing. That would be amazing because it's such a, I'm a huge fan of data loaders. Okay, because it's from my point of view, if you're talking GraphQL without talking about data loaders, you're making a disservice to everybody that is listening. That's listening, okay? Because if you're not using data loaders, you're risking yourself to build a ticking bomb to put a ticking bomb in your GraphQL implementation. So you need to implement data loaders to make good resolvers, essentially. So what's your strategy, Ido?
Our strategy is actually maybe going against what you're saying, and we don't use data loaders, but let me say why. So we use Postgres as a database, and given the nature of how Postgres works and the fact that it has such a strong JSON capabilities, I knew that instead of using data loaders, I can resolve every GraphQL query in just a single Postgres query, and getting rid of the n+1 problem and all of this. So what we ended up doing is we created kind of like internal library that using the metadata from the type ORM library that we use. So type ORM brings all the information about the relations between the different entities, the foreign keys and everything. So we take your GraphQL request, resolve tree, and then we generate an SQL statement that, using JSON capabilities, creates one query to resolve all your GraphQL tree in one shot. And this way we keep all our GraphQL requests with only one Postgres database, no matter how deep or what you need.
Amazing. Great. It will make a fantastic open source project, by the way. If you had to release it, that would be really, 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 really cool for everybody to see. Just recommendations, okay? Like make more open source stuff. Anyway,
we definitely need to do it. Yeah,
sure. It seems quite a nice library, because there are quite a lot of projects that are doing similar things, like Azura, PostgreSQL. They're doing similar things to what you said, but yours seems very specialized to your use case and performant. So it's a great story. So Ido, what can we expect from the future from GraphQL?
So actually, I'm not very much aware of the specs, but some of the things I saw in terms of GraphQL is something like, live query or something like this, that you dispatch a query and then you get first the response and then it turns to some kind of subscription. I don't know if I get it right or if you know it better than I do, but it will help you, keep your data up to date on the client side whenever there is a change in the query. So it will just keep the data coming. This is at least one of the key features that I'm waiting to land on GraphQL.
Amazing, but you will, like, for the live data, you will have to have some database support for it, right?
Yeah, I'm not sure how we will handle it, like, behind the scene, and how will the exact implementation be like. But it reminds me of this. There's a lot of hype right now on this kind of HTML over the wire.
Wow. Yeah, interesting.
Yeah, so this reminds me of this kind of stuff, where you first get some kind of response from GraphQL, and then you'll get the updates as you go, and you don't have to think about it. Yeah, I'm not sure how this will turn out and what the exact stage of this at this point.
Amazing. Okay. Great. Yeah, no, for me, it's, I think there is a lot of stuff coming through in the coming through in the GraphQL world around GraphQL Federation. I think there is a lot of I think it's a great pattern, and I think there is a lot of companies that are working to innovate into that space as part of from Apollo. So I think it's great. I was so sad to see Apollo doing using a non-permissive license for the next generation generation code. So I'm not so happy. I was not necessarily happy about it, but anyway, it's their choice. So they did that move, and they basically said how they see their product going. And it's but I think it's a great pattern. So I think more companies are working and building stuff with that. So it's going to, I think we're going to see more about GraphQL. There is also a lot of focus and research on how you can implement cross-cutting concerns on top of non-functional requirements on top of GraphQL, like caching. There's a lot of research on that. We are part of that, but there is a lot of it. Then we also have a lot of work on being on authentication and authorization on top of GraphQL systems. A lot of things happening in the space, so watch for it. I think it's this is an exciting space to be working in, and yeah, that was nice.
Yeah, for sure. And also you mentioned federation, and so one of the perks of Mercurius compared to other alternatives is that you support subscriptions, federated subscriptions out of the box. This was also caught my attention because I'm looking at federation and thinking, what happens when we want to scale our API to several microservices, and so having support for federated subscription is a key benefit for
sure. Well, I am a part of the Node.js streaming working group, so if we were not streaming subscriptions, we would do something wrong. I'm joking. It's we used a lot of it's funny because in the subscription implementation in Mercurius, we used a lot of the new APIs and new work that we have done added to Node streams in the years. So a lot of stuff that people don't really know about, and patterns that are not super widespread. So if you want to read it, you will see that the way we process this data, just like, did I know Node can do this type of discussions? Okay, like feeling. So it's great to see. Amazing.
Yeah, for sure.
I think if there are not more questions, I would say that we had a really good time, and I would thank everybody for watching, and thank Ido for joining me on today's today's webinar about Mercurius. And it was really great to see you. And we'll see each other at the next conference or events or something. I will really love to meet you in person at some point. It would be fantastic. We'll see when it will happen. Finger crossed.
Yeah. Thank you, Matteo. Thank you all the NearForm team, and thank you everyone who is watching. I had the best time, and yeah, make sure you can reach out on Twitter in the meantime until we meet face to face. And yeah, so that's all, I guess.
Perfect. Amazing. Bye-bye, folks. Bye.